Tonight, we are leaving Earth behind once again and drifting gently into the endless darkness of space, where strange and extraordinary worlds quietly circle distant stars. As you relax, imagine traveling through a peaceful universe filled with glowing suns, colorful nebulae, and mysterious planets unlike anything in our own solar system. Some of these worlds are made of scorching gas, some may be covered by endless oceans, and others experience weather so bizarre that it seems impossible. Everything in tonight's journey is based on real astronomical discoveries and scientific research. There will be no loud surprises or dramatic interruptions, only calm storytelling and fascinating science designed to help you unwind. So close your eyes, take a slow breath, and let us begin our peaceful voyage through the 10 weirdest planets in the universe. Planet 1. HD 189733b, the planet where glass falls like rain. Our first destination is a remarkable world called HD 189733b. This giant planet lies about 64 light-years away from Earth and has become one of the most famous exoplanets ever discovered. From a distance, it appears surprisingly beautiful, glowing with a rich, deep blue color that almost resembles Earth's oceans. For a moment, you might imagine a peaceful water world covered by calm seas and blue skies. But the reality is completely different. HD 189733b is a giant gas planet that orbits extremely close to its parent star. A single year on this world lasts only about 2 Earth days because it races around its star at incredible speed. Temperatures in its atmosphere reach nearly 1,000 degrees Celsius, making it hot enough to melt many types of rock. The atmosphere contains tiny particles of silicate minerals, the same materials that help create glass on Earth. Powerful winds, reaching speeds of about 8,700 kilometers per hour, hurl these particles sideways through the atmosphere. Instead of gentle rain falling downward, molten glass races horizontally across the sky. Astronomers often describe this weather as sideways glass rain. The very particles responsible for these deadly storms may also create the planet's beautiful blue appearance by scattering blue light through its atmosphere. It is a world where breathtaking beauty and extreme violence exist together in perfect contrast. Planet 2. WASP 12b, the planet being slowly consumed. Our next stop is a planet called WASP 12b. This enormous world is located about 1,400 light-years from Earth. It is so close to its parent star that the star's gravity is literally pulling the planet apart. Imagine a giant world slowly stretching like soft clay under the powerful pull of a nearby sun. The planet has become elongated rather than perfectly round. Astronomers believe that its atmosphere is constantly escaping into space. Streams of gas are being stripped away and absorbed by the nearby star. In a sense, the star is slowly consuming the planet. Temperatures on WASP 12b are estimated to exceed 2,500 degrees Celsius. The atmosphere glows with intense heat, creating a strange and dramatic appearance. Scientists think that the planet may eventually lose a significant portion of its mass. Over astronomical time, it could become smaller and smaller as its star continues feeding on it. This strange relationship between planet and star shows that even giant worlds can slowly disappear. Planet 3. Trace 2b, the darkest known planet. Now we travel to a world almost invisible against the darkness of space. This planet is called Trace 2b. It is one of the darkest planets ever discovered. While Earth reflects about 30% of the sunlight that reaches it, Trace 2b reflects less than 1%. It absorbs almost all of the light that falls upon it. If it were placed near our solar system, it would appear darker than charcoal and almost darker than black paint. Scientists believe its atmosphere contains chemicals that trap incoming light extremely efficiently. Despite being incredibly hot, the planet reflects almost nothing. Its darkness is so complete that it resembles a shadow floating through space. Astronomers studying it were surprised by how little light they could detect. A faint reddish glow may exist because of its extreme temperature. Otherwise, the planet remains almost completely hidden within the cosmic darkness. It is a reminder that not every world shines brightly among the stars. Planet 4. Kepler 16b, the real-life Tatooine planet. Our fourth world feels surprisingly familiar. Kepler 16b is often called the real-life Tatooine because it orbits two stars instead of one. Imagine standing on a distant world and watching two suns rise and set across the sky. The planet circles around both stars in a wide orbit. Its sunlight constantly changes as the two stars move around each other. Some days would be brighter than others. The shadows would be unusual, with two different light sources creating overlapping patterns. Seasons on this world could become surprisingly complex. The planet itself is a gas giant somewhat similar to Saturn. Although it is probably not suitable for life, its double-star system has fascinated astronomers around the world. It confirmed that stable planetary orbits can exist around two stars. For centuries, people imagined such worlds only in stories. Today we know that they truly exist. Planet 5. GJ1214b, the possible water world. Next we arrive at a mysterious planet called GJ1214b. This world is about 48 light-years away from Earth. It is larger than Earth but smaller than Neptune, placing it in a category known as a super-Earth or mini-Neptune. Scientists believe it may contain enormous amounts of water. Unlike Earth's oceans, however, this water may exist under incredible pressure. The planet could possess a global ocean hundreds or even thousands of kilometers deep. Beneath that ocean, water might transform into exotic forms of ice created by immense pressure rather than cold temperatures. Its atmosphere appears thick and cloudy. These clouds may hide the surface completely from view. Astronomers have struggled to determine exactly what lies beneath the clouds. Some researchers imagine a planet where endless water stretches in every direction. Others suggest a strange combination of steam, ice, and deep high-pressure oceans. It remains one of the most intriguing ocean world candidates ever discovered. Planet 6. 55 Cancri E, the planet of lava oceans. Our journey now reaches an incredibly hot rocky world called 55 Cancri E. This super-Earth orbits astonishingly close to its parent star. A year there lasts only about 18 Earth hours. The planet is tidally locked, meaning one side always faces the star while the other remains in permanent darkness. The day side is unimaginably hot. Temperatures may exceed 2,000 degrees Celsius. Scientists believe vast regions of molten lava could cover the illuminated side. Entire oceans of liquid rock may slowly flow across the surface. Volcanic activity might be extremely intense. The night side would be much cooler, creating enormous temperature differences across the planet. Astronomers have even detected variations in its heat emissions, suggesting changing volcanic conditions. It is a world where stone behaves almost like water. Planet 7. HAT P7b, the planet with sapphire rain. Our seventh destination is another strange giant world called HAT P7b. This planet experiences weather unlike anything found in our solar system. Its atmosphere contains aluminum oxide, a mineral closely related to sapphire and ruby. Powerful atmospheric circulation may transport this material across the planet. Scientists think that sapphire particles could condense and fall through the atmosphere. Imagine blue gemstone crystals forming high in the clouds. Strong winds then carry them across the sky before they descend again. The planet's weather patterns appear highly dynamic and constantly changing. One side is extremely hot while the other is cooler. These temperature differences drive powerful atmospheric currents. If sapphire rain truly occurs there, it would be one of the most extraordinary weather systems ever discovered. A distant world where precious gemstones may literally fall from the sky. Planet 8. Kepler. 10b. The ancient scorched world. Now we visit one of the oldest known rocky planets. Kepler. 10b is estimated to be more than 10 billion years old. That means this planet formed when the universe was still relatively young. It has existed for more than twice the age of Earth. The planet orbits very close to its star. Its surface is intensely heated. Scientists believe much of its rocky crust may be molten. The day side is blasted by relentless stellar radiation. The night side remains permanently dark. Because it is so old, this planet has survived billions of years of cosmic history. It may have witnessed changes in its star that occurred long before Earth even existed. A lonely ancient world glowing quietly in the darkness of space. Planet 9. PSRB 1620-26b, the planet older than almost everything. Our ninth world is sometimes called the Genesis planet. PSRB 1620-26b is estimated to be around 12.7 billion years old. It orbits a pulsar and a white dwarf, making its environment extremely unusual. This planet formed when the universe was very young. It existed before our sun was born, before Earth formed, before most of the stars visible in our night sky existed. The planet circles the remains of a dead star that emits powerful pulses of radiation. Its history spans almost the entire age of the cosmos. Imagine a world that has silently traveled through space for nearly 13 billion years. It has survived stellar explosions, galactic evolution, and countless cosmic events. Few known objects have such an ancient and extraordinary story. Planet 10. TOI 849b, the exposed planetary core. Our final planet tonight may be one of the strangest of all. TOI 849b appears to be the naked core of a giant planet. Astronomers believe it was once a massive gas giant similar to Jupiter. Over time, its thick atmosphere may have been stripped away. What remains is an enormous dense core exposed directly to space. The planet is extremely heavy for its size. Its interior may contain exotic high-pressure materials. Scientists had long wondered whether giant planetary cores could ever be observed directly. TOI 849b may provide that rare opportunity. It is like discovering the hidden heart of a giant world after its outer layers have vanished. A mysterious cosmic relic revealing the deep interior of a planet that was once much larger. As our journey through the first 10 weirdest planets comes to an end, let the images of blue glass storms, sapphire rain, lava oceans, ancient worlds, and exposed planetary cores slowly fade into the quiet darkness of space. The universe is far stranger than anyone once imagined, and tonight we have visited only a small handful of its extraordinary worlds. In the next part of our journey, we will continue exploring even more bizarre planets, including worlds that may float, worlds wrapped in endless clouds, and planets with weather beyond anything found on Earth. Until then, simply drift peacefully among the stars, and let the vast and mysterious universe carry you gently towards sleep. As we continue our peaceful voyage through the universe, the stars become even more numerous, and the familiar glow of our own sun is now only another tiny point among billions. Every direction reveals distant planetary systems, each with its own collection of remarkable worlds. Some are unimaginably hot, others endlessly cold, and many challenge everything we once believed about how planets form and evolve. Tonight, we gently drift toward 10 more of the strangest planets astronomers have ever discovered. Planet 11, WASP 17b, the backwards planet. Our next destination is a giant world called WASP 17b. At first glance, it looks like another enormous gas giant. But one remarkable detail makes it stand apart from nearly every other known planet. WASP 17b orbits its star in the opposite direction of the star's own rotation. Astronomers call this a retrograde orbit. Imagine every planet in our solar system moving counterclockwise around the sun. Now imagine one giant planet suddenly deciding to travel clockwise instead. That is essentially what happens here. Scientists believe this unusual motion may have resulted from a violent gravitational encounter billions of years ago. Perhaps another massive planet once passed nearby. Perhaps an ancient star disturbed the entire planetary system. Whatever happened, the result permanently changed this world's path. Even today, WASP 17b continues its lonely backwards journey through space, reminding us that the universe rarely follows simple rules. Planet 12, Kepler 7b, the cloud map planet. Floating peacefully ahead is Kepler 7b. This warm gas giant has become famous for something no one expected. Astronomers have actually mapped some of its clouds. Instead of being evenly covered, one side of the planet appears much brighter than the other. Scientists believe enormous reflective clouds gather across part of its atmosphere. These clouds may contain silicate minerals drifting high above the planet. Unlike Earth's constantly changing weather, these bright cloud formations may remain stable for very long periods. Imagine looking down from orbit and seeing continents made not of land, but of clouds. The planet teaches astronomers that weather on distant worlds can be surprisingly organized. Its atmosphere behaves almost like a slowly moving ocean suspended in the sky. Every new observation helps researchers understand alien climates a little better. Planet 13, HD 80606b, the planet of extreme seasons. Now we arrive at one of the most dramatic worlds ever discovered. HD 80606b follows an incredibly stretched orbit around its star. Instead of moving in a nearly perfect circle like Earth, it travels in a long oval. Most of the time the planet remains relatively far away. Then it suddenly dives incredibly close to its star. During these close approaches, temperatures rise by hundreds of degrees within only a few hours. Imagine winter suddenly transforming into an inferno before returning to cool conditions again. No place in our solar system experiences changes this extreme. The atmosphere rapidly expands as it heats, then slowly cools again as the planet travels away. It is one of the most extraordinary examples of extreme planetary weather ever observed. Planet 14, KLT 9b, the hottest planet known. Our journey now reaches one of the hottest planets ever discovered. KLT 9b is hotter than many stars. Its day side reaches temperatures of around 4,000 degrees Celsius. That is hot enough to vaporize many metals. Iron, titanium, even other heavy elements may exist as glowing gas. The atmosphere shines with incredible energy. Instead of gentle clouds, the skies may contain vaporized metals drifting through intense heat. Scientists sometimes describe it as a planet that almost behaves like a small star. Everything here exists under conditions almost impossible to imagine. Planet 15, HIP 65426b, the Lonely Giant. Next, we quietly approach HIP 65426b. This giant world is unusual because it orbits incredibly far from its parent star. While Neptune circles our Sun at about 30 astronomical units, this planet is much farther away. It takes centuries to complete a single orbit. Its star appears much smaller in its sky. The planet drifts through darkness with very little stellar warmth. Astronomers were surprised because giant planets usually form much closer to their stars. How this enormous world ended up so far away remains an ongoing mystery. Perhaps it formed elsewhere and slowly migrated outward. Or perhaps another giant planet pushed it away billions of years ago. Even today, scientists continue searching for answers. Planet 16, Corot 7b, the lava hemisphere. Now we visit another extraordinary rocky world. Corot 7b is so close to its star that one side permanently faces the sunlight. The bright side is covered by temperatures exceeding 2,000 degrees Celsius. Scientists believe rivers and lakes of molten rock may flow across its surface. Meanwhile, the opposite side remains locked in eternal darkness. There, temperatures are dramatically colder. The boundary between day and night may experience fierce winds as heat constantly tries to move across the planet. Imagine standing where glowing lava fields slowly disappear into endless darkness. It is one of the strangest landscapes astronomers have imagined. Planet 17, Kepler 70b, the planet that shouldn't exist. Ahead lies a tiny rocky world called Kepler 70b. Its parent star has already entered the later stages of its life. Normally, planets this close would have been destroyed when the star expanded into a giant. Yet somehow this little world survived. Astronomers still debate how. Perhaps it once orbited farther away. Perhaps it is the remaining core of a much larger planet. Its very existence challenges current theories of planetary evolution. Sometimes the universe preserves worlds where none should remain. That mystery continues to fascinate scientists today. Planet 18, HAT P32b, the puffy giant. Now we gently approach one of the least dense planets known. HAT P32b is enormous. Its diameter exceeds Jupiter's. Yet despite its tremendous size, its mass is surprisingly low. The planet is incredibly inflated. If an ocean large enough existed, this giant might theoretically float because its average density is lower than water. Its atmosphere stretches far into space. Scientists are still uncertain exactly why it became so swollen. Intense heating from its nearby star probably plays an important role. Even gas giants can become strangely oversized under the right conditions. Planet 19, LHS 1140b, a possible ocean super-Earth. Our next destination feels calmer. LHS 1140b is one of the most promising rocky planets discovered so far. It lies within the habitable zone of its parent star. Scientists believe liquid water might exist there under the right conditions. The planet is larger and heavier than Earth. Its gravity would feel stronger. If oceans exist, they could stretch across vast regions of the surface. A thicker atmosphere might help protect it from space radiation. Although no one knows whether life exists there, it remains one of astronomy's most exciting candidates. It reminds us that not every strange planet is hostile. Some may quietly resemble young versions of Earth. Planet 20, J1407b, the planet with giant rings. Our final destination tonight is truly breathtaking. J1407b may possess the largest ring system ever discovered. Its rings are absolutely enormous. If they replace Saturn's rings, they would dominate Earth's sky. Scientists estimate the ring system could be nearly 200 times larger than Saturn's. Inside these rings may be dozens of young moons still forming. Imagine looking upward and seeing gigantic glowing bands stretching from one horizon to the other. The rings would cast moving shadows across the planet below. Entire civilizations, if they existed, would grow up beneath an ever-changing sky of brilliant circles. Among all known planetary systems, few sights would be more spectacular. As we slowly leave these 10 extraordinary worlds behind, the silence of deep space grows even more peaceful. Ahead lie dozens more impossible planets, worlds that evaporate into space, planets hidden beneath endless clouds, wandering planets without stars, and mysterious giants that continue to puzzle astronomers. In the next part of our journey, we will continue exploring the strange and beautiful diversity of our universe, one calm discovery at a time. As we continue our peaceful journey, the Milky Way stretches around us like a glowing river of countless stars. Every tiny point of light may have its own family of planets, each shaped by different stars, different histories, and different laws of nature. Some worlds are so unusual that they seem to belong in dreams rather than reality. Yet each one reminds us that the universe is wonderfully creative. Tonight, we quietly drift toward 10 more of the weirdest planets ever discovered. Planet 21, PSOJ 318.5-22, the lonely wandering planet. Our next destination is unlike almost every other planet we have visited. This mysterious world, known as PSOJ 318.5-22, does not orbit a star at all. Instead, it travels alone through the darkness of interstellar space. Astronomers call such worlds rogue planets. No sunrise ever brightens its skies. No sunset marks the end of a day. It simply drifts silently between the stars, guided only by gravity. Scientists believe it may have formed around a young star before being thrown into deep space by powerful gravitational interactions. Although isolated, the planet still glows faintly from the heat left over from its formation. Imagine an endless night lasting billions of years. There is no familiar star overhead, only distant galaxies scattered across an eternal black sky. It is one of the loneliest worlds known in the universe. Planet 22, Gliese 436b, the planet with burning ice. Now we arrive at a world that seems to ignore common sense. Gliese 436b is famous for containing a strange form of water. Despite temperatures reaching nearly 400 degrees Celsius, scientists believe water may exist there as solid ice. This unusual material is called hot ice. The planet's enormous gravity squeezes water so tightly that it cannot expand into steam. Instead, it remains compressed into an exotic solid state. Here on Earth, heat melts ice. On Gliese 436b, tremendous pressure allows ice to survive where fire should exist. The atmosphere is also slowly escaping into space, creating a giant cloud trailing behind the planet. It is one of the most fascinating examples of physics behaving differently under extreme conditions. Planet 23, GJ367b, the Iron Planet. Floating quietly ahead is GJ367b. At first glance it appears to be a small rocky planet, but inside, it is remarkably different from Earth. Scientists estimate that most of its interior is made of iron. Much like Mercury, it possesses an unusually large metallic core. Its density is extremely high. The planet orbits so close to its star that 1 year lasts less than 8 Earth hours. The day side is blisteringly hot. Molten rock may cover much of its surface. It is a heavy, compact world that demonstrates how dramatically rocky planets can vary throughout the galaxy. Planet 24, Kepler 438b, Earth's mysterious cousin. Our next stop is Kepler 438b. This planet has often been compared to Earth because of its similar size. It circles within the habitable zone of its small red star. At first, scientists considered it one of the best candidates for life. But later observations revealed another mystery. Its parent star frequently produces enormous stellar flares. These powerful bursts of radiation may strike the planet over and over again. If the atmosphere is thin, such radiation could make the surface extremely hostile. If the atmosphere is thick, it might provide protection. Astronomers still do not know which possibility is correct. Kepler 438b remains one of the galaxy's most intriguing unanswered questions. Planet 25, TOI 700d, a calm ocean candidate. Now we gently approach TOI 700d. Unlike many extreme planets, this world appears surprisingly peaceful. It orbits inside the habitable zone of its quiet red dwarf star. Scientists believe temperatures could allow liquid water to exist. If oceans cover its surface, they may reflect the reddish light of its nearby sun. The sky would likely appear very different from Earth's. Sunrise might glow with deep orange and crimson colors. Although no evidence of life has been found, the planet continues attracting great scientific interest. Future telescopes may one day reveal the composition of its atmosphere. It represents hope in the search for another Earth. Planet 26, HD 149026b, the giant with a massive core. Our next destination hides an extraordinary secret beneath its clouds. HD 149026b is a gas giant. Yet scientists believe its solid core is enormous. The core may contain around 70 times the mass of Earth. That makes it much larger than expected for a planet of its type. How such a massive core formed remains uncertain. Perhaps it gathered material unusually quickly during the early stages of planetary formation. Or perhaps several young planets merged together. Whatever the explanation, this giant world continues challenging existing theories. Sometimes the biggest mysteries lie hidden deep beneath thick clouds. Planet 27, K2-141b, the rock rain planet. We now arrive at one of the strangest rocky planets ever discovered. K2-141b is so hot that rocks evaporate. The surface facing its star reaches temperatures above 3,000 degrees Celsius. Minerals become vapor just as water evaporates on Earth. Scientists believe these mineral vapors rise into the atmosphere. Powerful winds carry them toward the colder night side. There they cool and condense. Instead of water rain, molten rock falls from the sky. Rivers of lava may slowly flow back toward the hot side, completing an extraordinary rock cycle unlike anything in our solar system. Planet 28, Kepler 36b and Kepler 36c, the neighbors that shouldn't exist. Our next destination is actually a pair of remarkable planets. Kepler 36b and Kepler 36c orbit incredibly close to one another. Despite being neighbors, they are completely different. One is dense and rocky. The other is larger and wrapped in thick gas. At certain times they pass astonishingly close together. Their gravity slightly changes each other's orbits. Astronomers use these tiny orbital changes to measure their masses with great precision. This unusual pair demonstrates that neighboring planets can have dramatically different histories. Even planets born in the same system may evolve along completely separate paths. Planet 29, Beta Pictoris b, the young giant. Ahead shines Beta Pictoris b. Unlike ancient worlds, this giant planet is remarkably young. It is only about 20 million years old. Compared with Earth's age of 4.5 billion years, it is practically an infant. The planet is still glowing with leftover heat from its formation. Astronomers have directly photographed it, making it one of the few exoplanets ever seen in actual images. Powerful storms likely swirl through its atmosphere. Its thick clouds shine with a reddish glow. Studying this young giant helps scientists understand how planets form during the earliest stages of their lives. Planet 30, Kepler 452b, Earth's older relative. Our final stop tonight is Kepler 452b. This fascinating world is often described as Earth's older cousin. It is larger than our planet and orbits a star similar to the Sun. However, its star is much older. If the planet has oceans and continents, they have experienced billions of additional years of evolution. Perhaps towering mountain ranges have worn away. Perhaps ancient oceans have changed countless times. Scientists cannot yet see its surface, but they often imagine what an older version of Earth might look like. Kepler 452b reminds us that planets, like stars, continue changing throughout cosmic history. Some worlds may quietly age for billions of years beneath the light of distant suns. As we leave these 10 extraordinary planets behind, our voyage through the universe is only beginning. Ahead are even stranger destinations, diamond-like worlds, planets hidden inside dusty disks, frozen giants, ultralight planets, and mysterious super-Earths that continue to puzzle astronomers. With every gentle stop, we discover that the universe is far more imaginative than anyone once believed. The farther we travel from Earth, the quieter the universe seems to become. Around us, stars sparkle like tiny lanterns suspended in an endless sea of darkness. Every one of those stars may have its own remarkable family of planets, each shaped by billions of years of cosmic history. Some formed in peaceful surroundings, while others survived violent collisions and powerful gravitational forces. Tonight, we continue our gentle journey, discovering 10 more fascinating worlds whose stories remind us that the universe is full of wonderful surprises. Planet 31, HD 209458b, the evaporating planet. Our next destination is HD 209458b, one of the first exoplanets whose atmosphere was studied in remarkable detail. At first glance, it appears to be an ordinary gas giant. Yet this world is slowly disappearing. Because it orbits extremely close to its parent star, intense radiation constantly heats its upper atmosphere. The heated gases expand farther and farther into space. Eventually, gravity can no longer hold some of that gas. Hydrogen escapes, creating a gigantic cloud that trails behind the planet like the tail of a comet. Astronomers have actually observed this escaping atmosphere using powerful telescopes. Every second, the planet loses thousands of tons of gas. Fortunately for the planet, it is so massive that this process takes billions of years. Still, it reminds us that planets are not permanent. Even giant worlds slowly change with time. Planet 32, Wolf 503b, the planet between two worlds. Floating quietly ahead is Wolf 503b. This fascinating planet belongs to a rare category of worlds. It is larger than Earth, but smaller than Neptune. Astronomers are still uncertain exactly what it is. Could it be a giant rocky super-Earth? Or perhaps a small gas planet wrapped in a thick atmosphere? The answer remains unknown. Very few planets of this size have been studied in great detail. Wolf 503b may help scientists understand why planets tend to separate into either rocky worlds or gas-rich worlds. It sits almost perfectly between those two families. Sometimes the most mysterious planets are not the strangest looking. They are the ones that refuse to fit into familiar categories. Planet 33, Kepler 22b, the ocean world candidate. Now we arrive at one of astronomy's most famous discoveries. Kepler 22b was among the first planets found inside the habitable zone of a sun-like star. Scientists believe temperatures there could allow liquid water. Some researchers imagine enormous oceans stretching across the planet. Others think clouds may permanently blanket the sky. The world is larger than Earth, so its gravity would probably feel stronger. No one knows whether continents exist. No one knows whether rain falls. No one even knows whether the surface is solid. Yet Kepler 22b continues inspiring scientists searching for places where life might someday be discovered. Planet 34, HATS 6b, the giant around a tiny star. Our next stop demonstrates that nature often ignores expectations. HATS 6b is a gas giant. Its parent star, however, is surprisingly small. For many years, astronomers believed tiny stars could not easily produce giant planets. Yet HATS 6b proves otherwise. Despite orbiting a cool red dwarf, it grew into a massive world. Its existence challenges earlier models of planetary formation. Perhaps giant planets are more common than previously imagined. Perhaps small stars possess more surprising planetary systems than anyone expected. The universe enjoys keeping its secrets. Planet 35, Kepler 51d, the cotton candy planet. Ahead floats one of the fluffiest planets ever discovered. Kepler 51d is enormous. Its size rivals Jupiter, yet its mass is astonishingly small. Its density is so incredibly low that astronomers sometimes call it a cotton candy planet. If there were an impossibly large ocean, this world would theoretically float. Its atmosphere stretches thousands of kilometers into space. The gases are incredibly light and diffuse. Scientists still debate exactly how such an inflated atmosphere remains stable. Perhaps we are observing the planet during a brief stage of its evolution. One day it may shrink dramatically. For now, it remains one of the puffiest worlds ever found. Planet 36, TOI 270d, the hidden water giant. We now approach TOI 270d. This mysterious world lies somewhere between Earth and Neptune in size. Scientists suspect enormous quantities of water may exist deep inside. Not ordinary oceans like those on Earth. Instead, vast layers of superheated water compressed beneath thick atmospheres. The immense pressure could create exotic forms of water unknown on our planet. Above those layers may exist dense clouds rich in steam. Sunlight filters through the atmosphere in unfamiliar colors. Future telescopes may eventually reveal exactly what hides beneath those clouds. Until then, TOI 270d remains one of the galaxy's greatest mysteries. Planet 37, VHS 1256b, the planet with sand clouds. Our next destination is wrapped in extraordinary weather. VHS 1256b possesses enormous clouds made of silicate particles. These particles are similar to materials found in sand. High above the planet, tiny mineral grains drift through the atmosphere. Powerful winds continually reshape these cloud layers. Instead of water vapor, the skies contain minerals. The clouds glow faintly under the heat escaping from the young planet. Astronomers using the James Webb Space Telescope have studied these remarkable cloud structures in impressive detail. They provide one of the clearest views yet of weather on a distant giant planet. Planet 38, Kepler 90I, the newcomer. Now we visit one of the newest members of a remarkable planetary family. Kepler 90I was discovered using artificial intelligence. Scientists trained computer systems to search through enormous amounts of telescope data. Hidden among thousands of signals was this previously overlooked world. Its discovery marked an exciting partnership between astronomy and machine learning. The planet itself is a hot, rocky world orbiting close to its star. Although not especially large, its discovery method made history. Sometimes the greatest breakthroughs come not from new telescopes, but from new ways of examining old information. Planet 39, 2-mass J2126-8140, the extremely distant companion. Our next world follows one of the widest known planetary orbits. 2-mass J2126-8140 travels astonishingly far from its parent star. The distance is nearly 1 trillion kilometers. If Earth orbited that far away, the Sun would appear almost like another bright star. One complete orbit takes nearly 1 million Earth years. That means the planet has completed only a handful of years since dinosaurs disappeared. Its slow journey through space is almost impossible to imagine. The bond between planet and star is incredibly delicate, yet gravity continues holding them together across unimaginable distances. Planet 40, KLT 11b, the transparent giant. Our final destination tonight is KLT 11b. This enormous gas giant possesses one of the least dense atmospheres ever studied. Its atmosphere is remarkably clear. Unlike many gas giants hidden beneath thick clouds, astronomers can observe surprisingly deep into its gaseous layers. This transparency has made KLT 11b an important target for atmospheric research. Scientists have detected water vapor and other gases with unusual precision. Every observation teaches researchers more about how giant planets form and evolve. Although KLT 11b itself is far too hot for life, it serves as a valuable natural laboratory. Sometimes the strangest planets become the best classrooms for understanding the universe. Our peaceful voyage has now reached 40 extraordinary worlds. We have explored planets that evaporate into space, giants as light as cotton candy, worlds wrapped in mineral clouds, and planets whose years last nearly 1 million Earth years. Yet the universe still holds many more astonishing destinations. In the next chapter, we will continue our relaxing journey through planets that challenge imagination and expand our understanding of the cosmos, one quiet discovery at a time. The deeper we travel into the universe, the more extraordinary the scenery becomes. Around us, young stars are being born inside glowing clouds of gas, while ancient stars quietly approach the ends of their lives. Between them, countless planets follow paths shaped over billions of years. Some are battered by intense radiation, others drift peacefully through darkness, and a few continue to surprise astronomers every time they are observed. Tonight, we gently continue our journey toward 10 more remarkable worlds. Planet 41, HD 149382b, the survivor around a dying star. Our next destination is HD 149382b, a world that may have survived one of the most dramatic events in stellar evolution. Its parent star has already expanded far beyond its original size. Normally, planets orbiting this close would be swallowed completely. Yet evidence has suggested that this world may have escaped destruction. If it truly survived, it likely endured unimaginable heat as the star transformed into a red giant. Some astronomers think the planet may even have helped strip away the outer layers of its dying star. Although its existence remains debated, the idea is fascinating. It reminds us that planets and stars can influence each other's destinies. Sometimes a small world can leave a lasting mark on a much larger star. The universe often tells stories of survival against overwhelming odds. Planet 42, Kepler 62f, the distant blue hope. Now we arrive at one of the most promising Earth-sized worlds ever discovered. Kepler 62f circles quietly within the habitable zone of its parent star. It is about 40% larger than Earth. Scientists believe liquid water could exist there if the atmosphere is thick enough. Perhaps clouds drift above enormous oceans. Perhaps snow falls across distant mountains. Or perhaps the planet is entirely different from anything we have imagined. No telescope today can reveal its surface directly. Yet Kepler 62f continues inspiring scientists because it demonstrates that Earth-like planets may not be rare. Somewhere among the stars, peaceful blue worlds may quietly wait to be discovered. Planet 43, HD 106906b, the rebel giant. Floating far ahead is HD 106906b. This enormous gas giant follows one of the strangest orbits ever observed. It circles its star at a distance more than 700 times greater than Earth's distance from the Sun. Its orbit is so wide that astronomers struggle to explain how it formed. Perhaps another massive object pushed it outward billions of years ago. Perhaps it formed independently before becoming gravitationally attached. The planet spends centuries moving through deep darkness. Its parent star appears only as an exceptionally bright point of light. It is a lonely giant wandering along the outer edge of its own planetary system. Planet 44, Kepler 442b, one of the most Earth-like worlds. Our next stop is Kepler 442b. Many astronomers consider it one of the best candidates for long-term habitability. It is only slightly larger than Earth. Its orbit allows temperatures that could support liquid water. The planet receives less sunlight than Earth, creating a gentler environment. If forests exist there, they might grow beneath a softer orange sky. If oceans cover its surface, they could stretch peacefully across vast continents. Although life has never been detected, Kepler 442b reminds humanity that Earth may not be unique. The galaxy could contain countless similar worlds. Planet 45, NGTS 1b, the impossible giant. Now we visit another surprising gas giant. NGTS 1b orbits a very small red dwarf star. According to older theories, such tiny stars should rarely produce Jupiter-sized planets. Yet there it is, a massive gas giant quietly circling its small parent star. Its discovery forced astronomers to rethink important ideas about planet formation. Perhaps giant planets can form under a much wider range of conditions than expected. Every unexpected discovery improves our understanding of the universe. Sometimes nature creates worlds exactly where scientists thought they could never exist. Planet 46, Kepler 452c, a super-Earth under an older sun. Our journey continues toward Kepler 452c, often called Earth's older cousin. This planet orbits a star remarkably similar to our Sun. The difference is that its star has aged much more. Over billions of years, the star has gradually become brighter. If Kepler 452c once possessed comfortable temperatures, they may now be steadily increasing. Perhaps ancient oceans have begun evaporating. Perhaps climates have slowly changed over immense stretches of time. It offers scientists a possible glimpse into Earth's distant future. Studying this world helps us imagine what our own planet might become billions of years from now. Planet 47, K2-18b, the water vapor world. Ahead lies one of the most discussed exoplanets of recent years. K2-18b is larger than Earth, but smaller than Neptune. Astronomers have detected water vapor in its atmosphere. More recently, scientists have continued studying its atmospheric chemistry using advanced space telescopes. Some researchers think it could possess a deep ocean beneath a hydrogen-rich atmosphere. Others remain cautious, noting that many questions remain unanswered. Regardless of the final answer, K2-18b has become one of the most important planets in the search for potentially habitable environments. Each new observation reveals another piece of its mysterious story. Planet 48, Kepler 78b, the planet racing around its star. Our next destination moves with incredible speed. Kepler 78b circles its star in only about 8.5 hours. Its year is shorter than a typical workday on Earth. Because it remains so close to its star, temperatures are extraordinarily high. Its rocky surface likely glows with molten lava. The planet is slightly larger than Earth. Because of this uncertainty, GQ Lupi b has become an important object of study. Sometimes nature refuses to fit neatly into scientific definitions. Instead, it creates objects somewhere between familiar classifications. The universe often reminds us that reality is more complex than our labels. Planet 50, Proxima Centauri b, our closest neighbor. Our final destination tonight is perhaps the most famous nearby exoplanet. Proxima Centauri b orbits Proxima Centauri b, the closest known star to our solar system. Only a little over 4 light-years separate this world from Earth. Although that distance is enormous by human standards, it is remarkably close on the scale of our galaxy. The planet lies within the habitable zone of its small red dwarf star. If it possesses a thick atmosphere, liquid water might exist on its surface. Its sky would look very different from ours. Its small red sun would appear larger than Proxima Centauri appears from Earth. One day, future spacecraft may travel there, making it the first exoplanet humanity explores up close. For now, it remains a quiet neighbor waiting patiently among the stars. As we leave our 50th strange world behind, we have reached the halfway point of our extraordinary journey. We have wandered among evaporating giants, possible ocean planets, lonely gas worlds, and Earth's distant cousins. Yet even stranger destinations still await us. In the next chapter, we will continue exploring planets with extreme gravity, unusual atmospheres, and mysterious origins, drifting peacefully through the endless beauty of the universe. The universe never seems to run out of surprises. Even after discovering thousands of planets beyond our solar system, astronomers continue finding worlds that challenge every expectation. Some are so young that they are still glowing from their birth. Others are ancient travelers that have quietly circled their stars for billions of years. A few seem almost impossible, existing where no planet should survive. As we continue our peaceful voyage, let your imagination drift among 10 more extraordinary worlds that reveal just how diverse our galaxy truly is. Planet 51, Kepler 69c, the mysterious twin. Our next destination is Kepler 69c, a world that once captured the imagination of scientists around the world. When it was first discovered, many believed it could be an Earth-like planet. Its size is only slightly larger than our own world. It orbits a star somewhat similar to the Sun. Early calculations suggested it might lie within the habitable zone. Later research revealed that it probably receives much more heat than originally expected. Some scientists now compare it more closely to a hotter version of Venus. If thick clouds cover the planet, they may trap enormous amounts of heat. Despite this uncertainty, Kepler 69c reminds us how difficult it is to understand distant worlds. Even with powerful telescopes, every new discovery raises fresh questions. Planet 52, HR 8799e, the young giant. Ahead glows one of the few exoplanets that astronomers have photographed directly. HR 8799e belongs to a remarkable family of 4 giant planets orbiting the same young star. Unlike our mature solar system, this planetary system is still relatively young. The planet continues releasing heat left over from its formation. Its atmosphere glows with shades of deep red and orange. Powerful storms likely circle the planet for centuries. Clouds rich in minerals drift high above its atmosphere. Watching this young giant is like looking back in time to see how Jupiter may have appeared billions of years ago. It offers a rare glimpse into the early lives of giant planets. Planet 53, Kepler 10c, the Mega-Earth. Our next stop is a world once nicknamed the Mega-Earth. Kepler 10c is much larger and heavier than Earth. Scientists were surprised by its tremendous density. Instead of becoming a gas giant, this planet remained mostly rocky despite its enormous mass. For many years, astronomers believed rocky planets could not grow this large. Kepler 10c challenged that assumption. Its discovery forced researchers to rethink where the boundary between rocky planets and gas planets truly lies. Sometimes the universe quietly ignores the limits we expect. Planet 54, Tau Boötis b, the tidally locked giant. Floating quietly before us is Tau Boötis b. This massive gas giant orbits extremely close to its bright parent star. One side permanently faces the sunlight. The opposite side remains in endless darkness. Scientists believe fierce winds carry heat from one hemisphere to the other. The planet may also possess an unusually strong magnetic field. If so, powerful auroras could dance across its skies. Unlike Earth's gentle northern lights, these displays might stretch across enormous regions of the atmosphere. It is a world of endless day and endless night existing side by side. Planet 55, WASP 39b, the planet with carbon dioxide. Our journey now reaches WASP 39b. Although many giant planets have been studied before, this one became especially important after observations by the James Webb Space Telescope. Astronomers detected clear evidence of carbon dioxide within its atmosphere. This discovery demonstrated the incredible power of modern space telescopes. Scientists also found water vapor, sulfur dioxide, and complex cloud structures. These observations help researchers understand how planets form around distant stars. Every chemical signature tells another chapter of the planet's history. Even without landing there, we can slowly uncover the secrets hidden inside alien atmospheres. Planet 56, LTT 9779b, the desert planet. Ahead lies one of the rarest planets ever discovered. LTT 9779b exists inside what astronomers call the Neptune Desert. This region lies so close to stars that Neptune-sized planets are expected to lose their atmospheres. Yet somehow this remarkable world survived. Its thick atmosphere continues resisting intense stellar radiation. Scientists remain uncertain exactly why. Perhaps its gravity is stronger than expected. Perhaps it formed under unusual circumstances. Whatever the answer, LTT 9779b continues challenging theories of planetary evolution. Sometimes the rarest planets become the most valuable teachers. Planet 57, HD 40307g, a quiet candidate. Now we gently approach HD 40307g. This super-Earth orbits within the outer region of its star's habitable zone. If it possesses a suitable atmosphere, temperatures could allow liquid water. The planet is significantly heavier than Earth. Its gravity would feel noticeably stronger. A year there lasts almost 200 Earth days. Because its star is smaller than the Sun, daylight would appear softer. Scientists continue debating the exact properties of this intriguing world. Although many mysteries remain, it continues ranking among interesting candidates for future study. Planet 58, ROX's 42BB, the glowing young world. Our next destination is still glowing from its birth. ROX's 42BB formed only a few million years ago. Compared with Earth's age, it is almost a newborn. Its atmosphere remains extremely hot. Scientists believe thick clouds of dust and minerals swirl through its skies. Infrared observations reveal heat escaping from deep within the planet. Watching such a young world allows astronomers to witness the earliest stages of planetary evolution. It is like observing childhood on a cosmic scale. Planet 59, OGLE 2005, BLG 390LB, the frozen super-Earth. Far from the warmth of its parent star lies an icy world. OGLE 2005, BLG 390LB receives very little sunlight. Surface temperatures may fall below minus 220 degrees Celsius. If oceans ever existed there, they are now buried beneath thick layers of ice. Deep underground, however, pressure could allow liquid water to remain. Some scientists wonder whether hidden oceans might survive beneath frozen crusts. Similar possibilities exist on icy moons within our own solar system. Even worlds that appear frozen and lifeless may still hide remarkable secrets beneath their surfaces. Planet 60, HD 95086b, the Dusty Giant. Our final destination tonight circles a young star surrounded by enormous rings of cosmic dust. HD 95086b moves through this developing planetary system like a giant sculptor. Its gravity shapes the surrounding dust into graceful patterns. Scientists believe these dusty regions resemble the early solar system billions of years ago. Perhaps new planets are still forming there today. Watching HD 95086b is like looking into Earth's own distant past. Long before our oceans formed, our solar system may have appeared very similar. This young giant offers a peaceful glimpse into the beginning of planetary history. As we quietly leave these 10 extraordinary worlds behind, our journey reaches 60 planets explored. We have wandered among glowing newborn giants, frozen super-Earths, mysterious desert planets, and ancient rocky worlds that continue to challenge modern astronomy. Yet 40 more incredible destinations still await us. Beyond the next stars lie planets with incredible winds, unusual chemistry, and astonishing histories, waiting patiently for us to discover them as our peaceful voyage through the universe continues. Planet 61, HAT P11b, the planet with water vapor and powerful storms. As we continue drifting through the quiet darkness of our galaxy, another remarkable world slowly comes into view. This distant planet is known as HAT P11b, and it orbits a small orange-colored star located about 123 light-years away from Earth. Although it is smaller than Jupiter, It is much larger than our own planet, placing it into a fascinating category known as Neptune-like exoplanets. For many years, astronomers wondered what its atmosphere might contain. The answer finally arrived after careful observations using powerful space telescopes. Scientists detected clear evidence of water vapor high above its cloud tops. This discovery was especially exciting because thick clouds usually prevent astronomers from studying planets of this size. P11b turned out to have an unusually clear upper atmosphere, allowing tiny fingerprints of water molecules to become visible from across interstellar space. That achievement represented an important milestone in exoplanet science. Although water exists there, it is nothing like the gentle oceans or peaceful lakes we know on Earth. The temperatures are far too high for liquid water to remain stable. Instead, the water exists as invisible vapor mixed into a thick atmosphere of hydrogen and helium. Imagine floating high above this strange world. Below you, enormous cloud systems slowly stretch across the horizon. The clouds may appear pale blue, white, and silver as light from the nearby star filters through layers of gas. Far beneath those cloud tops, pressure steadily increases until the atmosphere becomes so dense that no spacecraft built today could survive the descent. Astronomers believe fierce winds race continuously around the planet. These powerful atmospheric currents transport heat from one region to another, creating weather patterns that may last for years or even centuries. Unlike Earth, there are no mountains to interrupt the wind. No forests slow the movement of air. Only endless layers of gas flowing around the entire planet in graceful, uninterrupted circles. If you could somehow remain safely suspended above the atmosphere, the view might be strangely peaceful despite the incredible violence taking place below. The planet quietly circles its parent star every few Earth days, completing a year long before Earth has even finished a single week. Its rapid orbit means daylight changes quickly, yet the planet itself remains locked in an endless dance with its nearby sun. Each discovery made on P11b reminds astronomers that planets come in astonishing varieties. Even worlds once thought impossible to study are slowly revealing their secrets. Every observation teaches us a little more about how planets form, how atmospheres evolve, and how diverse our galaxy truly is. As P11b slowly fades into the distance behind us, its shimmering clouds disappear into the darkness, leaving only the quiet glow of its distant star. Ahead, dozens more extraordinary worlds are waiting patiently among the stars, each with a story even stranger than the last. Planet 62, HD 189733c, the Giant Companion. Our journey now takes us deeper into the same remarkable planetary system that contains the famous glass rain planet. Farther away from the star quietly orbits another giant world called HD 189733c. Unlike its famous inner neighbor, this planet travels along a much wider path. Astronomers believe it may have played an important role in shaping the entire planetary system. Its powerful gravity could have influenced the orbit of HD 189733b billions of years ago. These slow gravitational interactions are common throughout the universe. Planets gently pull on one another over millions of years. Sometimes these tiny forces dramatically reshape entire solar systems. HD 189733c itself is thought to be a massive gas giant. Its thick atmosphere probably consists mostly of hydrogen and helium. Cloud layers may slowly drift beneath faint sunlight reaching from its distant star. If moons circle this giant world, They would experience breathtaking views of both the planet and the nearby stars. Although astronomers continue studying this system, many questions remain unanswered. The exact history of these two neighboring giants is still being pieced together. Every new observation helps scientists better understand how planetary families evolved together over billions of years. Planet 63, WASP 107b, the planet as light as cotton candy, floating quietly ahead, is one of the strangest giant planets ever discovered. Its name is WASP 107b. At first glance, it appears almost as large as Jupiter. Yet appearances can be wonderfully misleading. Despite its enormous size, the planet contains only a fraction of Jupiter's mass. Its average density is astonishingly low. Astronomers often compare it to cotton candy because it is so light for its size. Its atmosphere stretches far into space. Gravity holds the gases only gently, allowing the upper atmosphere to slowly escape into the darkness. Powerful ultraviolet radiation from its nearby star steadily pushes these gases outward. Scientists have even detected helium escaping from the planet like an enormous, invisible tail. If you could somehow float above its atmosphere, the horizon would appear incredibly broad because the clouds extend so far above the planet's interior. The cloud tops may glow softly beneath the light of their nearby sun. Deep below those clouds, pressure gradually increases until gases become unimaginably dense. WASP 107b reminds us that size alone does not determine what a planet is truly like. Sometimes the largest worlds can also be surprisingly light. Planet 64, TOI 1452b, the possible endless ocean. Our next destination feels calm compared with many worlds we have already visited. TOI 1452b is considered one of the most promising ocean world candidates discovered in recent years. The planet is slightly larger than Earth. Scientists estimate that an enormous amount of its total mass could consist of water. Imagine standing above a world where no continents ever break the surface. Instead, endless oceans stretch in every direction beneath a quiet sky. Those oceans could reach hundreds of kilometers in depth. Far below the upper waters, immense pressure would transform ordinary water into exotic forms of ice, unlike anything naturally found on Earth. Above the ocean, clouds may slowly drift through a thick atmosphere. Gentle sunlight from its small red star reflects across the endless waves. If marine life somehow existed there, it would experience a planet with no beaches, no mountains, and no forests. Only an endless blue world quietly circling its distant sun. Although astronomers cannot yet confirm whether such oceans truly exist, TOI 1452b remains one of the most fascinating places currently under investigation. Planet 65, HIP 99770b, a newly imaged giant. Our final destination tonight is one of the newest worlds to reveal itself directly to human eyes. HIP 99770b was photographed using advanced imaging technology, making it one of the relatively small number of exoplanets that scientists have actually seen rather than merely detected indirectly. This young gas giant still glows with heat left over from its formation. Unlike older planets that have cooled over billions of years, HIP 99770b continues radiating energy into space. Its atmosphere probably contains thick clouds of dust and glowing gases. Powerful storms may slowly circle the planet for many years at a time. Its parent star shines brightly in the distance, illuminating the giant world with soft golden light. Astronomers treasure directly imaged planets because they allow much more detailed study than most distant worlds. Each photograph contains valuable clues about temperature, atmospheric chemistry, cloud structure, and planetary evolution. HIP 99770b is therefore much more than another giant planet. It is a window into the early lives of massive worlds forming throughout our galaxy. As we quietly drift away, its warm glow slowly fades into the darkness, joining countless other distant lights scattered across the endless universe. As these 5 remarkable planets disappear behind us, the silence of space grows deeper once again. We have explored crystal-clear atmospheres, feather-light gas giants, endless ocean candidates, and newly imaged worlds that are still glowing from their birth. Yet our journey is far from over. Ahead, even stranger planets await, each carrying another peaceful story among the stars. As our quiet journey continues, the familiar stars of Earth's night sky are now far behind us. We drift gently through one distant planetary system after another, each one shaped by its own unique history. Some planets have survived violent cosmic events, while others are still glowing from their formation. Every discovery reminds us that the universe is far more creative than anyone imagined only a few decades ago. Tonight, let your breathing slow as we visit 5 more extraordinary worlds, each stranger than the last. Planet 66, HD 80606b, the planet with the most extreme seasons. Our next destination is HD 80606b, one of the most dramatic planets ever discovered. Unlike Earth, which follows a nearly circular path around the Sun, this remarkable world travels in an extremely stretched, oval-shaped orbit. For much of its long journey, the planet remains relatively far from its parent star, where temperatures are comparatively calm for a hot gas giant. Then, during one brief part of its orbit, everything changes. The planet plunges toward its star at tremendous speed. Within only a few hours, its atmosphere is blasted by an enormous increase in heat. Scientists estimate that temperatures can rise by several hundred degrees in an incredibly short time. Imagine experiencing the cold of winter in the morning and the intense heat of a volcanic desert before nightfall. No planet in our own solar system experiences such dramatic seasonal changes. The atmosphere responds immediately. Powerful winds begin racing across the planet as hot gases expand. Gigantic storms may form while the atmosphere struggles to distribute the sudden burst of energy. After passing close to the star, the planet slowly moves away once again. Temperatures gradually fall. The violent storms weaken. For many months, the world quietly cools before repeating the entire cycle again. This endless rhythm of heating and cooling has likely continued for billions of years. HD 80606b reminds us that a planet's orbit can shape its climate just as much as its atmosphere. Planet 67, GJ 1132b, the planet that may have rebuilt its atmosphere. Our next stop is a small rocky world called GJ 1132b. At first glance, it appears to be another hot Earth-sized planet orbiting close to a small red dwarf star. For many years, scientists assumed that intense stellar radiation would have stripped away its atmosphere long ago. But recent observations suggest something far more fascinating. Researchers believe the planet may have created a second atmosphere. Deep inside GJ 1132b, volcanic activity could still be occurring. As volcanoes erupt, they release gases trapped beneath the surface. Over millions of years, these gases may slowly rebuild an atmosphere that had previously been lost. If this idea is correct, the planet is constantly renewing itself. Its landscape may be covered by dark volcanic plains stretching toward distant horizons. Cracks in the crust could glow faintly with rivers of molten rock. Above, a hazy atmosphere slowly forms from gases released by countless eruptions. Although far too hot for life as we know it, GJ 1132b teaches astronomers that planets are not lifeless rocks. Many continue changing long after their formation. Even billions of years later, a planet can still reinvent itself. Planet 68, WASP 121b, the planet where metals evaporate. Floating ahead is one of the hottest planets ever observed. Its name is WASP 121b. This giant world orbits so close to its parent star that one side is heated beyond imagination. Temperatures become so extreme that ordinary metals cannot remain solid. Scientists have detected vaporized iron, magnesium, calcium, and other heavy elements within its atmosphere. Imagine looking toward the daytime sky. Instead of ordinary clouds, glowing streams of metal vapor drift through scorching winds. Some of these materials may rise high into the atmosphere before cooling. Astronomers believe that on the cooler night side, some vaporized metals may condense once again. In a sense, the planet experiences an exotic weather cycle unlike anything on Earth. Here, rocks and metals behave almost the way water behaves in our atmosphere. The entire planet exists under conditions so extreme that chemistry itself begins to look unfamiliar. Despite the incredible heat, WASP 121b has become one of the best laboratories for studying exotic planetary atmospheres. Every observation reveals another surprising detail hidden within its glowing skies. Planet 69, Kepler 1649c, the quiet, Earth-sized neighbor. Our next destination feels noticeably calmer. Kepler 1649c is one of the closest known matches to Earth's size. It circles a cool red dwarf star within a region where temperatures may allow liquid water. Although the planet receives less sunlight than Earth, it still receives enough energy to attract great scientific interest. No one knows what its surface looks like. Perhaps vast oceans quietly reflect the reddish glow of its parent star. Perhaps mountain ranges rise through thick clouds. Or perhaps the world is covered by endless volcanic plains. Scientists simply do not know. That mystery is part of its beauty. Unlike many bizarre planets dominated by impossible temperatures, Kepler 1649c represents possibility rather than certainty. It reminds humanity that somewhere among billions of stars, another peaceful rocky world may quietly exist. Future telescopes may one day reveal the composition of its atmosphere. Until then, it remains one of astronomy's most hopeful discoveries. Planet 70, AB Aurigae b, a planet still being born. Our final destination tonight is extraordinary because it may not have finished forming. Known as AB Aurigae b, this young world circles a brilliant star surrounded by enormous clouds of gas and dust. Unlike mature planets that have existed for billions of years, AB Aurigae b is still in its infancy. Astronomers believe they are witnessing the early stages of planetary birth. The young planet continues gathering gas and dust from the enormous disk surrounding its star. Every orbit allows it to grow a little larger. Powerful gravity slowly shapes the material around it, carving graceful spiral patterns through the dusty disk. Imagine watching an entire planet gradually emerge from a swirling cosmic cloud. This process once occurred in our own solar system more than 4.5 billion years ago. Today, we can only imagine what young Earth looked like. But AB Aurigae b offers a rare opportunity to witness that ancient chapter unfolding around another star. It is not simply a planet. It is a world still writing the very first pages of its own history. As we quietly leave this newborn giant behind, we are reminded that somewhere across the galaxy, new planets are being created every single day, continuing the endless story of the universe. As Part 8 comes to a peaceful close, we have now visited 70 of the weirdest planets known to science. Ahead lie 30 more extraordinary destinations, including worlds with giant moon systems, mysterious atmospheres, unusual chemistry, and planets that continue to challenge everything astronomers thought they understood about how planetary systems evolve. As we continue our gentle voyage through the Milky Way, the silence of space grows even deeper. The brilliant stars around us seem almost motionless, although each one is racing through the galaxy at incredible speed. Somewhere around many of these distant suns, planets quietly complete their endless orbits, unaware that a small civilization on Earth has begun discovering them. Every new telescope reveals another hidden world, another strange atmosphere, another unexpected landscape. Tonight, we continue our relaxing journey toward 5 more remarkable planets whose stories stretch across billions of years. Planet 71, Kepler, 16b, the planet with 2 sunrises. Our next destination is the unforgettable world known as Kepler 16b. Unlike Earth, which circles a single sun, Kepler 16b travels around 2 stars at the same time. This type of orbit is known as a circumbinary orbit. For countless generations, worlds with 2 suns existed only in mythology and science fiction. Today, astronomers know they are completely real. Imagine standing high above this giant planet's cloud tops. Slowly, 2 glowing stars begin rising together over the horizon. One star appears larger and brighter. The other is slightly smaller and dimmer. As they move across the sky, their combined light constantly changes. Sometimes they drift close together. Sometimes they move farther apart. Shadows would shift throughout the day in ways impossible on Earth. The sky itself would never look exactly the same twice. Because the 2 stars orbit each other, the changing patterns of daylight would create seasons unlike anything our own world has ever experienced. Kepler 16b is a gas giant similar in size to Saturn, with no solid surface to stand upon. Beneath its upper clouds lie enormous layers of hydrogen and helium compressed under immense pressure. Far below, temperatures and pressure become so great that the gases gradually behave more like liquids than ordinary air. Although life as we know it is unlikely there, the planet demonstrates one remarkable truth. Nature has no difficulty building stable worlds around not 1 sun, but 2. For anyone drifting peacefully through space, watching twin sunsets disappear beyond the horizon would surely be among the most unforgettable sights in the galaxy. Planet 72, Kepler 1708b, the planet that may have a giant moon. Our next stop takes us to a world that has generated enormous excitement among astronomers. Kepler 1708b is a massive gas giant orbiting a distant star hundreds of light years away. By itself, the planet is already fascinating, but scientists believe it may possess something even more extraordinary. Evidence suggests that it could be accompanied by a gigantic moon. If confirmed, this would become one of the first convincing discoveries of a moon orbiting a planet outside our solar system. The possible moon may be almost as large as Neptune. That is far larger than any moon orbiting a planet in our own solar system. Imagine looking upward from this enormous moon. The parent planet would dominate the sky. Its colorful cloud bands could stretch from one horizon to the other. Storm systems larger than Earth might slowly rotate across its atmosphere. The reflected light from the giant planet would softly illuminate the moon's nights. Just as our moon influences Earth's tides, this enormous companion may produce tremendous gravitational effects. The dance between planet and moon would continue for billions of years in perfect silence. Although astronomers are still collecting evidence, the possibility alone reminds us that the universe may contain planetary systems even more spectacular than our own. Planet 73, Gliese 1214b, the Steam World. Floating peacefully ahead is the mysterious planet known as Gliese 1214b. Ever since its discovery, astronomers have debated exactly what lies beneath its thick atmosphere. Many scientists believe this remarkable world may be covered by an enormous global ocean. Unlike Earth's familiar seas, however, these waters would exist under extraordinary conditions. Temperatures are much higher. Pressures are almost unimaginable. The upper atmosphere may contain thick layers of water vapor that stretch for thousands of kilometers. Below those clouds, the atmosphere gradually becomes denser and hotter. Far beneath the surface, pressure may transform ordinary water into exotic forms of high-pressure ice. These unusual forms of ice remain solid despite incredible temperatures because gravity compresses them so tightly. There may be no beaches, no islands, no continents, only an endless ocean reaching downward far beyond anything humans have ever experienced. If sunlight filters through the atmosphere, it might create soft shades of blue and silver across the cloud tops. The entire world could resemble one enormous shimmering pearl drifting through space. Although no spacecraft has visited this distant planet, it remains one of the strongest candidates for a true ocean world beyond our solar system. Planet 74, Isis 2b, the planet that should not be there. Our journey now brings us to one of astronomy's newest puzzles. The giant world called Isis 2b circles its young parent star at an astonishing distance. In fact, it is so far away that existing theories struggle to explain how it formed. Normally, giant planets are expected to grow much closer to their stars, where more building material is available. Yet Isis 2b quietly orbits hundreds of astronomical units away. Its parent star appears only as an exceptionally bright point of light. The journey around its sun takes thousands of Earth years. Perhaps another giant planet pushed it outward long ago. Perhaps it formed directly from a collapsing cloud of gas far from the star. Astronomers still do not know. The planet itself is still young enough to glow faintly with leftover heat from its formation. Its atmosphere probably contains swirling clouds rich in dust and hydrogen. Watching this distant giant is like opening a book whose final chapters have not yet been written. Every new observation has the potential to completely change our understanding of planetary formation. Planet 75, 51 Pegasi b, the planet that changed astronomy forever. Our final destination tonight is one of the most historically important planets ever discovered. Its name is 51 Pegasi b. Before its discovery in 1995, astronomers strongly believed that planetary systems around other stars would closely resemble our own solar system. Then 51 Pegasi b completely overturned those expectations. This giant planet orbits astonishingly close to its sun-like star. A single year there lasts only about 4 Earth days. No one expected a Jupiter-sized world to exist so near its parent star. Its discovery forced scientists to rewrite textbooks and rethink decades of planetary theory. Today, planets like this are known as hot Jupiters. Since then, astronomers have discovered hundreds of similar worlds across the galaxy. Although 51 Pegasi b is far too hot for life, its scientific importance cannot be overstated. Without this remarkable planet, the modern search for exoplanets might have progressed much more slowly. It opened humanity's eyes to an entirely new category of worlds. Sometimes the most extraordinary planets are not the strangest because of their appearance. Sometimes they are extraordinary because they forever change the way we understand the universe. As we quietly leave these 5 fascinating worlds behind, our peaceful journey reaches 75 planets explored. Only 25 extraordinary destinations remain. Ahead lie mysterious super-Earths, distant giants, hidden ocean candidates, and planets whose unusual atmospheres continue to surprise even the world's leading astronomers. Each one carries another quiet story waiting to unfold among the endless stars. As we continue drifting through the vastness of the Milky Way, the silence around us feels almost timeless. Stars shimmer like tiny lanterns scattered across an endless velvet sky, each surrounded by invisible worlds quietly following ancient paths. Some of these planets are so young that they are still glowing from their birth, while others have witnessed almost the entire history of our galaxy. Every one has a story that stretches across millions or even billions of years. Tonight, we gently explore 5 more extraordinary destinations, allowing the calm beauty of the cosmos to slowly carry us toward peaceful sleep. Planet 76, TOI 1338b, the planet with 2 dancing suns. Our next destination is the remarkable world known as TOI 1338b. Like the famous Kepler 16b, this fascinating planet circles not 1 star, but 2. Its journey through space is a graceful dance around a pair of suns that continuously orbit one another. Imagine standing high above its cloud tops and watching 2 glowing stars slowly move across the sky. Some mornings, both stars would rise together. On other days, one sun might appear first, followed by the second a little later. The changing positions of the stars would constantly reshape the daylight. Shadows would stretch in different directions as the twin suns crossed the heavens. No 2 sunsets would ever look exactly the same. One evening, the brighter star might disappear first. Another evening, both stars could sink below the horizon almost together. The changing light would create an ever-shifting rhythm that repeated over months and years. TOI 1338b itself is a large gas giant with no solid ground beneath its thick atmosphere. Beneath its colorful cloud layers, pressure steadily increases until gases are compressed into forms unlike anything found on Earth. Scientists believe powerful winds constantly circulate through the atmosphere, carrying heat from one region to another. Despite its strange environment, the planet demonstrates that stable worlds can exist even in the complex gravitational embrace of 2 stars. For anyone watching from a safe distance, the slow ballet of twin suns would surely be one of the most peaceful sights in the universe. Planet 77, Kepler 413b, the planet with a wobbling orbit. Floating quietly ahead is one of the strangest worlds ever discovered. Its name is Kepler 413b. At first glance, it appears to be another giant planet orbiting 2 stars. But this world hides a remarkable secret. Its orbit is tilted. As it travels around its parent stars, the entire orbit slowly wobbles over time. Astronomers compare this gentle motion to the slow wobble of a spinning toy top. Because of this unusual movement, the amount of sunlight reaching different parts of the planet changes constantly. If the planet possessed large moons, their skies would never follow predictable seasonal patterns. Years might pass with long periods of stable daylight before gradually shifting into entirely different lighting conditions. The stars would appear to wander across the sky in beautiful but complicated patterns. Scientists believe gravitational interactions between the two parent stars create this extraordinary orbital motion. Although the planet itself is likely a gas giant, its unusual orbit has become an important laboratory for understanding complex planetary systems. Kepler 413b reminds us that not every orbit is simple or perfectly steady. Even the paths planets follow through space can possess elegant and unexpected rhythms. Planet 78, HD 100546b, a giant still growing. Our next destination is one of the youngest giant planets astronomers have ever studied. Known as HD 100546b, this world may still be gathering material from the enormous disk of gas and dust surrounding its young star. Imagine traveling back more than 4.5 billion years to witness the birth of Jupiter. That may be something very similar to what astronomers are observing here. The young planet continues collecting hydrogen, dust, and rocky material from its surroundings. Powerful gravity slowly shapes the enormous disk into graceful rings and spiral structures. Every orbit adds a little more mass to the growing giant. Its atmosphere glows warmly because it still contains tremendous amounts of leftover heat from its formation. Thick clouds of dust may surround the planet, making direct observations difficult. Yet every image captured by modern telescopes reveals another small piece of this remarkable story. Instead of seeing a finished world, astronomers are witnessing a planet still under construction. It is a beautiful reminder that somewhere in the galaxy, new planetary systems are being born even today. Planet 79, KLT 20b, the planet orbiting a blazing white star. Ahead shines one of the brightest stars we have encountered on our journey. Orbiting it is the remarkable giant planet KLT 20b, also known as Mascara 2b. Unlike many hot Jupiters that orbit cooler stars, this world circles a brilliant white A-type star. Its parent star is much hotter and more luminous than our own sun. The planet receives an astonishing amount of radiation every moment of every day. Temperatures soar to well above 2,000 degrees Celsius. Scientists have detected traces of vaporized metals within its atmosphere. Strong ultraviolet radiation constantly reshapes the upper layers of gas. Powerful winds likely race from the intensely heated day side toward the cooler night side. The atmosphere may glow faintly beneath the brilliant white light of its nearby star. If viewed from a safe distance, the contrast between the dazzling star and the dark planet would create one of the most dramatic scenes in the galaxy. KLT 20b reminds us that even giant planets must adapt to the extraordinary conditions created by different kinds of stars. Every planetary system writes its own unique story. Planet 80, HD 106906b, the lonely giant at the edge of its system. Our final destination tonight is the mysterious giant HD 106906b, one of the most distant known planets from its parent star. It orbits at an astonishing distance of more than 700 times the distance between Earth and the Sun. To appreciate that scale, imagine placing Neptune where Earth now orbits. Then continue traveling outward for hundreds of additional Earth-Sun distances. Only then would you finally arrive at this lonely world. From the planet's perspective, its parent star would appear as an exceptionally bright point of light rather than a blazing sun filling the sky. A single orbit takes roughly 15,000 Earth years. Since the earliest human civilizations appeared, the planet has completed only a tiny fraction of 1 year. Astronomers remain uncertain how such a giant planet reached this extraordinary distance. Perhaps another massive planet scattered it outward billions of years ago. Perhaps a passing star disturbed its orbit during the early history of the system. Whatever the explanation, HD 106906b continues quietly circling its distant sun through the darkness of space. It is one of the loneliest known giants in our galaxy, reminding us that even planets can spend billions of years traveling through almost complete solitude. As we leave these 5 remarkable worlds behind, our peaceful expedition has now reached 80 of the weirdest planets known to science. Only 20 extraordinary destinations remain. Ahead are planets hidden in thick clouds, ancient giants older than Earth itself, mysterious super-Earths, and worlds that continue to challenge even the most advanced astronomical theories. With every quiet stop, the universe reveals another gentle reminder that reality is often far stranger and far more beautiful than imagination alone. Our journey carries us even farther from the familiar neighborhood of our solar system. The sun is now just another tiny star among hundreds of billions scattered across the Milky Way. Around us, immense clouds of glowing gas slowly give birth to new stars, while ancient planetary systems continue their quiet dance that began billions of years before life appeared on Earth. Every world we visit tonight has followed its own extraordinary path through cosmic history. Some challenge the way planets are supposed to form, while others possess environments so unusual that they seem almost impossible. As we continue drifting peacefully through the darkness, let your mind relax and imagine 5 more remarkable planets waiting among the stars. Planet 81, HIP 65426b, the giant with an endless year. Our next destination is the magnificent world known as HIP 65426b. This enormous gas giant was one of the first exoplanets to be photographed in remarkable detail by the James Webb Space Telescope. Unlike many giant planets that orbit close to their stars, HIP 65426b travels along a path incredibly far from its parent sun. Its journey is so wide that one complete year would last several centuries by Earth's calendar. Imagine watching a sunrise that changes so slowly that dozens of human generations would pass before the planet completed a single orbit. The young giant still glows warmly with heat left over from its birth. Instead of reflecting only starlight, it produces a faint glow of its own. Its atmosphere is believed to contain hydrogen, helium, and enormous clouds made from tiny particles of silicate dust. These mineral clouds may slowly drift through the upper atmosphere, creating constantly changing patterns. Powerful winds likely circle the planet at tremendous speeds, yet from far away the giant appears perfectly calm. Because the planet is still relatively young, astronomers believe it is continuing to cool very slowly. Every million years, it becomes just a little darker. Eventually, billions of years from now, it will resemble the colder giant planets found in older planetary systems. Watching HIP 65426b is like looking back to the childhood of Jupiter. It allows scientists to understand how giant planets evolved during the earliest chapters of their incredibly long lives. Planet 82, Kepler 1514b, the inflated giant. Our next stop is the fascinating world called Kepler 1514b. At first glance, it seems to be an ordinary gas giant, but careful measurements revealed something surprising. The planet is much larger than expected for its mass. Its atmosphere has become greatly inflated by the intense heat from its nearby star. Instead of remaining compact like Jupiter, the gases have expanded outward, making the planet appear much larger than it otherwise would. If 2 giant planets with identical masses were placed side by side, Kepler 1514b would look noticeably bigger simply because its atmosphere has swollen under constant heating. Scientists continue studying these inflated planets because they reveal how powerful stellar radiation can reshape entire worlds. The upper atmosphere probably extends thousands of kilometers above the deeper layers below. Clouds rich in hydrogen compounds may slowly drift through the sky, illuminated by warm golden light from the nearby star. Far beneath those clouds, pressure increases until gases become compressed into dense, exotic forms. Despite its enormous size, the planet remains surprisingly light for its volume. It reminds us that even giant planets are not rigid objects. They gently expand and contract as their environments change over billions of years. Planet 83, Trace 4b, one of the largest puffy planets ever found. Floating peacefully ahead is the extraordinary world known as Trace 4b. For years, this planet puzzled astronomers because it seemed almost impossibly large. Its diameter is significantly greater than Jupiter's, yet its mass is comparatively small. The result is one of the lowest density planets ever discovered. Astronomers often describe it as another member of the puffy planet family. If such an enormous world could somehow be placed into an equally enormous ocean, its average density suggests it could theoretically float. Of course, no ocean remotely large enough exists anywhere in the universe. Still, the comparison helps us appreciate just how unusual the planet truly is. Scientists believe intense heating from its nearby star causes much of this remarkable inflation. The atmosphere extends far into space, becoming thinner and thinner with altitude. High above the cloud tops, escaping gases slowly drift away into the darkness. Below, gigantic storms likely move across the atmosphere, although no solid surface lies beneath them. Trace 4b demonstrates that some of the galaxy's largest planets are also among its lightest. Planet 84, Captain B, the Ancient Traveler. Our journey now reaches one of the oldest known planetary systems ever discovered. The quiet rocky world called Captain B circles an ancient star known as Captain Star. This remarkable system formed roughly 11 billion years ago. To appreciate that age, remember that Earth itself formed about 4.5 billion years ago. Captain B may therefore be more than twice as old as our own planet. Imagine how much cosmic history this world has witnessed. When Captain B was already ancient, our solar system did not yet exist. When the first oceans formed on Earth, Captain B had already completed billions of orbits. The planet likely survived countless nearby supernova explosions, changing stellar neighborhoods, and the slow evolution of the Milky Way itself. Although scientists continue debating whether the planet lies comfortably within the habitable zone, its extraordinary age alone makes it fascinating. If Rocky Mountains exist there, they have stood beneath alien skies for billions of years longer than any landscape on Earth. Captain B reminds us that some planets have histories almost beyond human imagination. Planet 85, HAT P67b, the giant with the escaping atmosphere. Our final destination tonight is the remarkable HAT P67b. This enormous gas giant is among the least dense planets ever discovered. Its atmosphere is so extended that gravity struggles to hold on to its outermost layers. Powerful radiation from the nearby star steadily heats the upper atmosphere. As those gases become hotter, they slowly expand into space. Astronomers believe the planet is continuously losing part of its atmosphere through this process. Yet because the giant contains such an enormous amount of gas, this slow escape may continue for millions or even billions of years. The planet itself is several times larger than Jupiter in diameter, but much less dense. If viewed from orbit, its upper atmosphere would likely appear soft and hazy, blending almost seamlessly into the darkness of space. The boundary between the planet and outer space becomes surprisingly difficult to define. Where exactly does the atmosphere end? Even scientists sometimes struggle to answer that question for planets like this. P67b reminds us that planets are not always sharply defined objects. Sometimes they gradually fade into space itself, becoming part of the universe that surrounds them. As we quietly leave these 5 remarkable worlds behind, our relaxing voyage reaches 85 extraordinary planets. Only 15 destinations remain before our grand tour of the weirdest planets in the universe is complete. Ahead lie even more astonishing worlds, planets with unusual chemistry, mysterious origins, powerful magnetic fields, and environments unlike anything ever imagined when humanity first looked up at the night sky. The deeper we travel into our galaxy, the more peaceful the universe begins to feel. There is no sound in the vacuum of space, no wind rushing past, and no waves crashing against distant shores. Instead, everything moves with quiet patience. Stars slowly orbit the center of the Milky Way over hundreds of millions of years. Planets circle their suns without ever growing tired, repeating the same graceful paths for billions of years. Tonight, we continue our gentle voyage, visiting 5 more extraordinary worlds that remind us how wonderfully diverse our universe truly is. Planet 86, GJ357d, the super-Earth at the edge of warmth. Our next destination is the fascinating world known as GJ357d. This rocky super-Earth quietly orbits a cool red dwarf star located only a few dozen light years from Earth. Although it is much larger than our own planet, it receives a similar amount of energy to what Mars receives from the Sun. At first, that might sound far too cold. However, astronomers believe that if GJ357d possesses a thick atmosphere rich in greenhouse gases, it could still maintain temperatures warm enough for liquid water. Imagine standing beneath a sky where the sun appears smaller and glows with a gentle reddish-orange light. The daylight would be softer than Earth's, creating long, peaceful shadows across the landscape. If oceans exist, they might remain calm beneath layers of slowly drifting clouds. Towering mountain ranges could rise from ancient continents that have never been seen by human eyes. Or perhaps the world is covered entirely by rocky plains shaped by billions of years of meteorite impacts. Scientists simply do not know. That uncertainty is part of its beauty. Every observation collected from distant telescopes reveals only small clues. The complete story of GJ357d still waits patiently to be discovered. It reminds us that many of the galaxy's greatest mysteries may exist on worlds that look surprisingly ordinary from afar. Planet 87, Pi Minci c, the neighboring super-Earth. Our journey continues toward Pi Minci c, one of the closest known super-Earths to our solar system. This remarkable planet circles a bright sun-like star that can even be seen with the naked eye from dark locations on Earth. Unlike many giant planets, Pi Minci c is a rocky world several times more massive than Earth. A single year there lasts only a few days because it orbits very close to its parent star. The intense heat likely prevents liquid water from existing on its surface. Instead, enormous rocky plains may bake beneath relentless sunlight. Some scientists believe parts of the surface could consist of partially molten rock. Volcanic activity might still reshape the landscape today. Although it would be far too hostile for life as we know it, the planet is extremely valuable to astronomers. Because it is relatively nearby, future telescopes may study its atmosphere in remarkable detail. Each new observation helps scientists better understand how rocky planets evolve around stars similar to our own Sun. Planet 88, Corot 9b, the gentle giant. Floating quietly ahead is the peaceful giant known as Corot 9b. Unlike most hot Jupiters that race around their stars in just a few days, this enormous planet follows a much wider orbit. Its distance from its star allows much cooler temperatures. In many ways, astronomers consider it one of the closest known relatives of Jupiter beyond our solar system. Its atmosphere probably consists mostly of hydrogen and helium, with layers of ammonia and water clouds hidden deep below. Gentle sunlight reaches the upper atmosphere, producing a calm golden glow. Storms almost certainly exist, but they may develop more slowly than those on intensely heated giant planets. Its year lasts many months instead of only a few days. That slower rhythm gives the planet a peaceful quality compared with many of the extreme worlds we have already visited. Studying Corot 9b helps scientists understand what giant planets similar to Jupiter may look like around other stars. Sometimes the most unusual discovery is finding a world that feels unexpectedly familiar. Planet 89 had P26b, the unexpectedly simple atmosphere. Our next destination is the intriguing planet hat P26b, roughly the size of Neptune. This distant world surprised astronomers when they examined its atmosphere. Many planets of similar size possess thick clouds that hide everything below. Hat P26b was different. Its atmosphere turned out to be remarkably clear. This allowed scientists to detect water vapor and measure its chemical composition with unusual precision. Even more surprising, the atmosphere appears to contain fewer heavy elements than expected. That suggests the planet may have formed in a different way from Neptune. Perhaps it gathered gas unusually early during the formation of its planetary system. Or perhaps it migrated inward after forming much farther from its parent star. Every answer raises another fascinating question. The clearer atmosphere has transformed Hat P26b into one of the best laboratories for studying the evolution of Neptune-sized worlds. Sometimes the greatest discoveries happen because a planet simply allows us to see a little deeper. Planet 90, HD 3167c, the world of powerful winds. Our final destination tonight is the extraordinary HD 3167c. This planet belongs to a fascinating planetary family containing several very different worlds orbiting the same star. HD 3167c itself is believed to possess a thick atmosphere surrounding a solid interior. Scientists suspect powerful winds constantly race through its upper atmosphere. Because the planet orbits relatively close to its star, one side may receive much more heat than the other. That temperature difference drives enormous atmospheric circulation. Imagine clouds racing around the entire planet at speeds far greater than the strongest hurricanes ever recorded on Earth. Far below those clouds, pressure steadily increases into regions no spacecraft could currently survive. Astronomers continue studying this unusual world because it lies in an important size range between Earth and Neptune. Planets like HD 3167c may represent one of the most common types of world in our galaxy. Yet our own solar system contains nothing quite like them. Its existence reminds us that our planetary family is only one possible arrangement among countless others spread throughout the Milky Way. As these 5 remarkable planets slowly disappear into the darkness behind us, our peaceful expedition reaches 90 extraordinary worlds. Only 10 destinations remain before our grand journey comes to an end. Ahead lies some of the newest discoveries in exoplanet science, along with several legendary worlds whose unusual characteristics continue to inspire astronomers around the globe. Soon, our voyage through the 100 weirdest planets in the universe will reach its unforgettable conclusion. The stars around us seem almost endless now. Looking in every direction, countless tiny lights stretch toward horizons that have no beginning and no end. Each one may host its own collection of planets, quietly orbiting in perfect silence. Some of these worlds have existed since long before Earth was born. Others are still taking shape inside swirling disks of dust and gas. Together, they tell the story of a universe that has never stopped creating. As we continue our peaceful journey, allow yourself to drift a little farther into the calm darkness as we visit 5 more extraordinary planets near the end of our grand tour. Planet 91. Ross 128b, the quiet neighbor. Our next destination is Ross 128b, one of the most peaceful-looking worlds discovered close to our solar system. It orbits a small red dwarf star located only about 11 light-years from Earth. Unlike many red dwarfs that frequently unleash violent stellar flares, Ross 128 is considered relatively calm. That immediately attracted the attention of astronomers searching for stable planetary environments. Ross 128b is slightly larger than Earth and likely consists mostly of rock. If it possesses a substantial atmosphere, temperatures could allow liquid water under the right conditions. Imagine standing beneath a dim orange sky while a quiet crimson sun slowly climbs above the horizon. The daylight would be softer than Earth's, almost like an endless evening. Long shadows might stretch across ancient valleys carved by billions of years of geological activity. Perhaps vast plains of dark volcanic rock cover much of the surface. Or perhaps oceans quietly reflect the reddish light of the small star overhead. No one knows exactly what this world looks like. Yet its peaceful parent star makes Ross 128b one of the most fascinating nearby candidates in the search for potentially habitable planets. It reminds us that sometimes the quietest stars may provide the safest homes for distant worlds. Planet 92, TOI 700e, a small world in a remarkable family. Our journey continues toward the fascinating TOI 700e. This small rocky planet belongs to the remarkable TOI 700 planetary system, which contains several Earth-sized worlds. Unlike many of the giant planets we have visited, TOI 700e is only slightly smaller than Earth. It circles its cool red dwarf star at a distance that allows moderate temperatures. Although scientists cannot yet confirm the existence of water, the planet remains one of the most promising nearby rocky worlds. Imagine endless coastlines stretching beneath gentle reddish sunlight. Clouds drift quietly through a peaceful atmosphere. Small waves roll across broad oceans under skies unlike any seen on Earth. Perhaps forests grow beneath the orange glow of the distant star. Perhaps frozen mountains rise above quiet valleys. Or perhaps the landscape is completely barren, shaped only by wind and time. Astronomers continue studying this planetary system because it offers several different worlds to compare. Each planet provides another clue about how rocky worlds develop around small stars. TOI 700e reminds us that neighboring planets can follow remarkably different evolutionary paths despite forming together. Planet 93, WD 1856 plus 534b, the planet that survived a stellar death. Floating silently ahead is one of the most extraordinary survivors known to astronomy. Its name is WD 1856 plus 534b. This enormous gas giant circles a white dwarf, the tiny, incredibly dense remnant left behind after a star exhausts its nuclear fuel. Long ago, the original star expanded into a giant, likely swallowing any nearby planets. Yet somehow this remarkable world survived. Scientists believe it may once have orbited much farther away before gradually migrating inward after the star completed its dramatic transformation. Imagine witnessing a sunset where the sun is no longer a blazing yellow star, but a brilliant white ember only slightly larger than Earth. The sky would feel strangely quiet. The parent star would appear small but dazzlingly bright. The planet itself continues faithfully circling this stellar remnant, carrying the memory of a solar system that no longer exists. Its survival demonstrates that planetary systems can endure even after their stars experience catastrophic changes. Among all the strange worlds in our galaxy, WD 1856 plus 534b stands as one of the greatest symbols of endurance. Planet 94, LP 791 to 18d, the world of endless volcanoes. Our next destination is LP 791 to 18d, a rocky super-Earth that may be one of the most volcanically active planets ever discovered. Scientists believe the planet experiences enormous tidal forces caused by the gravity of neighboring planets. Those gravitational forces continually stretch and squeeze its interior. A similar process powers the volcanoes on Jupiter's moon Io. On LP 791 to 18d, however, the effect could be even greater. Deep beneath the surface, molten rock constantly shifts and churns. Gigantic volcanoes may erupt across the landscape on a regular basis. Rivers of lava could flow through enormous valleys before cooling into fresh volcanic plains. Ash clouds might rise high into the atmosphere before slowly settling back onto the surface. The constant recycling of rock may even help replenish the atmosphere over long periods of time. Although the environment would be far too hostile for humans, this extraordinary world provides astronomers with a valuable opportunity to study how tidal heating shapes rocky planets across the galaxy. It is a reminder that gravity itself can become a powerful engine driving planetary evolution. Planet 95, Epsilon Eridani b, a young giant around a nearby star. Our final destination tonight is the fascinating giant Epsilon Eridani b. This planet circles one of the closest sun-like stars to Earth, only about 10.5 light-years away. Its parent star is much younger than our Sun, making the entire planetary system resemble a younger version of our own solar system. Astronomers have detected vast belts of icy debris surrounding the star, somewhat similar to our asteroid belt and Kuiper belt. Epsilon Eridani b quietly moves among these ancient rings of ice and rock. Its gravity likely shapes the surrounding debris, guiding countless comets and smaller objects through the system. Imagine standing on a large moon orbiting this giant planet. Above you, the enormous striped world dominates the sky. Beyond it, countless icy fragments sparkle like distant diamonds beneath the light of a youthful sun. Scientists continue studying this nearby system because it may reveal how our own solar system looked billions of years ago. It is not merely another gas giant. It is a living snapshot of planetary youth, offering clues about the early history of worlds much closer to home. As these 5 remarkable planets fade gently into the darkness, our relaxing journey reaches 95 extraordinary worlds. Only 5 planets remain before our grand exploration of the 100 weirdest planets in the universe is complete. Our final chapter will take us to some of the most mysterious, beautiful, and scientifically important worlds ever discovered, bringing our peaceful voyage across the galaxy to a memorable and calming conclusion. Our peaceful journey is nearly complete. Far behind us, our own solar system has become only another tiny neighborhood among hundreds of billions scattered throughout the Milky Way. The stars surrounding us shine with quiet patience, just as they have for countless ages. Every planet we have visited has told a different story. Some were worlds of endless fire, where rocks evaporate into glowing clouds. Others were frozen giants drifting through darkness, while a few hinted at vast oceans hidden beneath thick atmospheres. Together they have shown us that the universe is not only larger than we imagine, but also far more creative. Tonight, we visit the final 5 extraordinary planets on our journey. As we slowly drift from one world to the next, allow your breathing to become slower, your thoughts lighter, and your imagination to float peacefully among the stars. Planet 96, L98 to 59F, the hidden ocean candidate. Our first destination tonight is L98 to 59F, a possible world that may exist in the fascinating L98 to 59 planetary system. Astronomers have already confirmed several rocky planets orbiting this nearby red dwarf star. Computer models suggest there could also be another distant member of the family. That possible world is known as L98 to 59F. Although it has not yet been confirmed beyond all doubt, scientists continue searching for evidence of its existence. If the planet is real, it may orbit within a region where temperatures could allow liquid water under suitable atmospheric conditions. Imagine a quiet ocean stretching beneath a deep blue sky, tinted with shades of crimson from its small red sun. Gentle waves move endlessly toward distant horizons that no explorer has ever reached. Clouds drift silently overhead while the star slowly rises through the morning mist. Perhaps enormous ice caps rest near the poles. Perhaps endless seas cover the entire planet. Or perhaps the world is a barren rocky landscape waiting for future telescopes to reveal its true appearance. Whether confirmed or not, L98 to 59F represents something beautiful about astronomy. Sometimes the search itself is just as exciting as the discovery. Each observation brings humanity one step closer to understanding what truly exists among the nearby stars. Planet 97, Teegarden Star B, one of the most Earth-like worlds. Floating peacefully ahead is Teegarden Star B, one of the closest potentially habitable rocky planets ever discovered. It circles a tiny red dwarf that is one of our nearest stellar neighbors. Despite the star's small size, the planet receives an amount of energy surprisingly similar to what Earth receives from the Sun. Scientists believe the world is probably rocky. Its mass is only slightly greater than Earth's. If it possesses a protective atmosphere, liquid water could potentially exist across parts of its surface. Imagine walking through quiet valleys beneath a warm reddish sky. The little sun would appear larger than many people expect because the planet orbits much closer than Earth orbits the sun. Gentle winds might carry mist across broad lakes. Mountain ranges could stand beneath billions of stars visible in the dark night. Because the star burns fuel extremely slowly, it may continue shining for trillions of years. That means worlds like Teegarden Star B could remain stable long after our own sun has reached the end of its life. Few planets better illustrate how different and how long-lived the universe can be. Planet 98, PSR B1620-26b, the ancient planet. Our next destination carries one of the most extraordinary nicknames in astronomy. PSR B1620-26 B is often called the Methuselah planet because of its incredible age. Scientists estimate that it formed around 12.5 billion years ago. That makes it one of the oldest known planets in the universe. When this ancient world first began circling its stars, the Milky Way itself was still young. Earth would not exist for another 8 billion years. The planet orbits a remarkable pair consisting of a white dwarf and a rapidly spinning pulsar. A pulsar is the dense remnant of an exploded massive star that rotates with astonishing precision. Imagine standing on a distant moon and watching a tiny, brilliant white star accompanied by the rhythmic flashes of a pulsar. Few places in the universe would offer such an unusual sky. For billions upon billions of years, this ancient planet has silently survived dramatic stellar evolution, cosmic collisions, and the changing structure of our galaxy. It is a living witness to nearly the entire history of the Milky Way. Its story reminds us that some planets have existed for almost as long as the universe itself. Planet 99, TRAPPIST-1e, the jewel of a remarkable planetary family. Our journey now reaches one of the most famous planetary systems ever discovered. Our destination is TRAPPIST-1e, one of 7 rocky worlds orbiting the tiny red dwarf star known as TRAPPIST-1. Among all 7 planets, many scientists consider TRAPPIST-1e one of the most promising candidates for maintaining liquid water. Its size is remarkably similar to Earth's. Its density suggests a rocky composition. If oceans exist there, they may gently reflect the deep crimson glow of the parent star. Because all 7 planets orbit extremely close together, neighboring worlds would appear as bright disks crossing the sky. Some might even appear larger than our own moon looks from Earth. Imagine watching another inhabited-looking planet slowly rise above the horizon. The night sky would never feel empty. Every evening could bring the beautiful sight of nearby sister worlds drifting silently overhead. Astronomers continue studying the TRAPPIST-1 system because it offers an extraordinary natural laboratory for understanding how multiple rocky planets evolve around one small star. It remains one of humanity's greatest hopes in the continuing search for life beyond Earth. Planet 100, Earth, the weirdest planet of all. For our final destination, we return home. After traveling across countless light years and visiting 99 extraordinary worlds, we arrive once again at Earth. At first, Earth may seem ordinary. After all, it is the world we know best. But viewed through the eyes of the universe, our home is wonderfully strange. It is a rocky planet covered by vast liquid oceans that shimmer beneath a breathable atmosphere. Life fills nearly every corner of its surface. Tiny bacteria thrive deep beneath the ground. Towering forests breathe with the changing seasons. Whales sing across immense oceans. Birds navigate continents using invisible magnetic fields. Millions of species share one small blue world orbiting an average yellow star. Earth possesses drifting continents that slowly reshape the planet over millions of years. Its magnetic field shields life from harmful radiation. Its moon stabilizes its rotation and gently lifts the tides. Its atmosphere creates blue skies, brilliant sunsets, rainbows, snowflakes, gentle rain, and the air that every living creature breathes. Most astonishing of all, this tiny planet produced curious minds capable of wondering what lies beyond its own sky. The atoms inside every human body were forged long ago inside ancient stars. In a very real sense, the universe has become aware of itself through the life that exists here. Among all the strange worlds we have explored, Earth remains unique, not because it is the largest, hottest, or oldest, but because it is the only planet we know that is filled with life, stories, music, dreams, and people looking up at the stars and asking questions. Perhaps that makes our home the weirdest and most beautiful planet of all. A peaceful good night. Our journey through 100 of the weirdest planets in the universe has now come to a gentle end. Together we have wandered among planets where molten rock falls like rain, worlds with two suns, ancient planets older than Earth itself, lonely giants drifting through the darkness, possible ocean worlds, newborn planets still taking shape, and distant rocky cousins that may one day reveal signs of life. Every one of these remarkable worlds reminds us that the universe is endlessly creative. Beyond every star lies the possibility of another story waiting to be discovered. As you continue to relax, imagine yourself floating peacefully among the countless stars of the Milky Way. There is no hurry here, only quiet light, only endless space, only the gentle rhythm of planets faithfully circling their distant suns. May the calm silence of the cosmos surround you. May your thoughts drift as softly as starlight. May your dreams carry you across peaceful galaxies filled with wonder. And as another quiet night settles over our own extraordinary little planet, close your eyes, breathe slowly, and let the infinite universe gently guide you into a deep, restful sleep. Good night, and thank you for traveling among the stars.